This is the simplest shot for the encoder to deal with. The background is defocused and there's pretty well no movement, so it's relatively easy for the encoder to predict what's going to happen and throw away the information that doesn't change. This means it's ideal for half-channel HDR. This is the same size shot, but now the background is in focus. This can make it look like there's a chroma key or a green screen being used, so if you can, it is better to defocus the background. It also means that because there's more detail, the encoder has to work harder to process the picture. In this shot, the camera's moving steadily, but there's nothing happening in the background, so it should work reasonably well. This is because the encoder can get rid of a lot of extraneous information that the eye won't notice. But it's much harder when you zoom out, because in this case, everything in the background is changing completely as the camera pulls out. And if it's a fast zoom, it almost certainly won't work at low data rates. That's when BGAN HDR really comes into its own. Of course, you won't necessarily be using crash zooms when you're doing lives, but this type of shot's likely to be very common. There's lots of activity, a busy background, and people even walking around in front of the camera. And that means there's just too much information to deal with at low bandwidths. And that means that you will get pixelation and breakup. And then, if you add a camera move, that's when it gets really challenging. And it's when the advantage of BGAN HDR can really be seen. Because what it allows you to do is get on with reporting the story without having to stand still or worry about what's happening around you. Or with interviewing a guest. BGAN HDR really does give you the capability of a low-end VSAT. And that means that you can pan and zoom between the reporter and an interviewee, and you can do that with a picture quality that won't look out of place on a primetime bulletin.